So in this video, we're just going to practice with different polyatomic ion names and formulas, and then get to some transition metal names and formulas. The thing about doing this is, from experience, it's a little bit difficult, or it can be a little bit difficult at first, but it gets a lot easier with practice. All right, things start to become a lot more familiar, and you know what to look for. All right, so one of the things that you're going to want to make sure that you have handy is your reference guide. All right, so the reference guide, which is you should already have, it's posted on the on my Canvas page in one of the earlier pages, but on excuse me, on page, I guess this is page 7 of the reference guide, you have this list of polyatomic ions. All right. And each of these polyatomic ions has a name, all right? NH4, all right, so whenever you see NH4, that's a polyatomic ion. Its charge is +1, that its name is ammonium, all right? So BrO3 with the -1 charge, that's bromate, all right? One thing I want to point out about doing these polyatomic ions, I'm actually not a big fan of the way that they put these in the reference guide. So, for example, I use bromate here as an example. I much prefer when you write this to put all the elements in parentheses with the charge on the outside. So I'll show you that in a second here. So instead of the way that they show in the reference guide, I prefer to put the atoms in parentheses and put the charge on the outside. Okay, so the first example that we're going to come to is potassium sulfite. All right, so first of all, how do we know that this is a polyatomic ion? All right, so the ones that are monatomic ions end in "ide." So this is not sulfide, this is sulfite. All right, and a quick way to quick rule of thumb is anything that ends in "ite" or "ate" is going to generally be a polyatomic ion. So notice the names of all these polyatomic ions. There's an 8 right here, 8, 8, 8, ite, 8, 8, 8, ite. All right, so there's only a couple of examples that go against this. One of them is cyanide, but notice all of the other ides that we've dealt with before, like sulfide, oxide, correspond to a specific element, like oxide is for oxygen. There is no cyan on the periodic table, all right? Also, the other exception is hydroxide, and you can tell that that's actually 2 elements. Hydr, that's for hydrogen, and then the ox for oxygen, so that's 2 elements, all right? So with the exception of those, all of your negatively charged polyatomic ions end in either 8 or ite. The only positively charged polyatomic ion is ammonium. All right, so that should be fairly easy to remember. All right, so what we're going to do, we need to apply the crisscross rule. And so we need to write down the atoms. All right, so potassium, its charge is +1. All right, and then we need to figure out what sulfite is. And if you look at the polyatomic ion and you're scrolling through this, and you find at the bottom you have sulfite right here, and it gives you the formula. And again, put the atom quantities in parentheses, put the charge on the outside. So this part right here is the potassium part of it, and this part right here is the sulfite part of it. And now we're just going to crisscross these the way that we did the regular ionic compounds, where we're going to take whatever this number is right here, we're going to put it down there, and we're going to take whatever number would be right here, and that's going to be a 1. You just don't write it when you do just a +1 charge, and you're going to put that on the outside of the parentheses. All right, so after you do this, this becomes K2, leave the parentheses in, SO3 parenthesis, and then you're going to you would put a 1 there. All right, or at least for now, let's put a 1 there. So the next thing that we need to do is simplify this, all right, or see if we can simplify it. All right, so the first thing that you want to look at is there a simpler ratio for the things that we did the crisscross rule for. All right, so 2 to 1. All right, there is no, that's a fully simplified ratio. All right, the only thing that we can simplify is that we don't put ones in. All right, so that would become K2 SO3. All right, and then the last thing that we do has to do with parentheses. All right, and I'm just going to use a math example. So if I showed this expression right here in math, 2 times parentheses a plus 3b, all right, in parentheses. All right, it would be fine to leave something like that. All right, I know that we could distribute that. All right, but I want to compare that to 1 times parentheses a plus 3b. All right, and hopefully you realize that you would never leave something like this, because multiplying 1 by this doesn't do anything, and this would just simplify down to a plus 3b. All right, because anything times 1 is itself. All right, so in the same way we do that, anytime you ever have 1 of something in one of a polyatomic ion, you don't need the parentheses. So what we're going to do is we're just going to drop the parentheses. All right, and it becomes that formula. All right, so just remember that rule. Anytime you have 1 of a polyatomic ion, drop the parentheses. All right, let's move on to the next one, ammonium chloride. All right, so going back to our chart, you can see that ammonium is NH4 with a +1 charge. So again, put the atom quantities in parentheses, put the charge on the outside. Remember, we might drop the parentheses later, but the best way to learn this is leave them in and then make the decision to take them out at the end if you can. All right. One thing I want to point out about this compound, it's reversed of the top compound. At the top, we had a monatomic cation with a polyatomic anion. All right. Here, we have a polyatomic cation with a monatomic anion. All right. But we're going to do this the same way. All right. We take the number here, and we're going to put it down there. We take whatever the number is here, and we're going to put it after the second one. All right, and that, again, let's leave the parentheses in for now. NH4, parenthesis, and the number that goes down there, the number that goes down here comes from there, that's going to be a 1. And then the Cl, the number that goes down there, is going to be a 1. All right, and then we're going to clean this up. All right, and I'm going to skip one step. So 1 to 1, we drop the 1s. Okay, so getting rid of both of these 1s, we now have a polyatomic ion right here that we only have 1 of. So we're going to drop those parentheses. So that's just going to become NH4Cl. Okay, all right. So this one right here, I'm going to do this a little bit quicker. Magnesium hydroxide. Magnesium is Mg plus 2. Hydroxide, we're going to get from the polyatomic ion chart. That is OH with a minus charge. All right. One thing, people often get this one wrong. But one thing I want to point out about, and I think the reason that people get it wrong is that when you have a bunch of these, when you have a bunch of atoms like NO2, for some reason people remember to put the parentheses there better when it's just two atoms like this. Make sure you put the parentheses around the elements, no matter how simple it looks. All right. So we're going to take this, put it down there. Take this one, put it over here. All right, so that becomes Mg, that's going to be a 1. And then parentheses OH. And notice that we have a 2 that goes down there. So we're going to put the 2 there. All right, and so then you have to look, how can we simplify this? All right, well, we don't put 1s in formulas. But this one, so a 1 to 2 ratio is fully simplified, but we don't put 1s in there. So we can get rid of the 1, all right? But the question is, can we get rid of the parentheses? All right, and the thing is here, you have to leave the parentheses in. All right, what this is saying is you have 2 units of everything which is in there. All right, notice what would happen if you left them out. MgOH2. All right, what that would tell you in this formula right here, you would assume that there's only 1 oxygen in that formula. But the way you read it here, you would see that there's 2 in there. All right, so make sure that you don't drop the parentheses here. All right, calcium carbonate. Calcium is +2. Carbonate is CO3 -2. We're going to crisscross these. All right, so take the 2, put it down there. Take this 2, put it on the outside of the other one, and this becomes Ca2 parentheses CO3 2. All right, now take a look at these, the numbers that we just created after we crisscrossed. 2 to 2. All right, that is the same thing as a 1-to-1 ratio. So we're going to reduce that to a 1-to-1 ratio. So Ca 1, and I think you guys can probably see where this is going. All right, so that becomes a 1-to-1 ratio. And now we can both get rid of the 1s and we can get rid of the parentheses. This is CaCO3, calcium, which is calcium carbonate, which, by the way, if you ever eat a Tums, all right, just like the thing for indigestion, those tablets are almost pure calcium carbonate. Okay, one last one, ammonium chromate. All right, the thing that's different about this is in this, both the cation and the anion are polyatomic ions. All right, so NH4 plus, and then what is chromate? So chromate I can see down here is CrO4 with a excuse me, a -2 charge. Okay, crisscrossing these guys, I'm going to get, so we're going to move that down there. We're going to move the 1 over here, parentheses, NH4 2, parentheses, CrO4, parentheses, 1. All right, and then what you can see here, we need to evaluate the ratios, the 2 and the 1. All right, that's fully simplified, but we know that we can take the 1 out, we drop the 1, and if there's only 1 of a polyatomic ion, you don't need the parentheses. This one right here, you've got 2 of this polyatomic ion. You do need the parentheses over here. So this is going to become NH4 2. Let me move my window over just a tad. Oops. All right, NH4 with the 2 after it, and CrO4. All right, notice no parentheses after that. All right, so we are going to move on to coming up with the names, and those are actually a little easier. All right, so one of the biggest issues in doing this is dividing the compounds into the positive part and the negative part. All right, so when we look at these, there's 2 ways that we can determine something is ionic. All right, and so the first is if it starts with a metal, and the second thing is if it starts with ammonium. Okay, and if you remember from the first simple compounds, we said that ionic compounds were a metal and a non-metal. All right, we're going to expand that a little bit and say that ionic compounds are going to start with either a metal or ammonium. All right, because ammonium is another way that you can have an ion at the beginning, because ammonium is itself an ion. All right, so notice that each of these, metal, metal, and then ammonium, so all of these are ionic. All right, we'll continue with this in the next video.